When people look up at the sky, they usually take the sun for granted. It rises every morning, sets every evening, warms the earth, brings light, and life goes on. Yet behind this daily routine hides an astonishing truth. Our existence depends entirely on a single star. Without it, we would be nothing. That is why the thought of what would happen if the sun suddenly exploded is both fascinating and terrifying. Even though such an explosion is not a real threat, imagining the consequences is both instructive and chilling. The sun is not fire in the ordinary sense. It is a gigantic sphere of plasma, where, under extreme conditions in its core, atoms of hydrogen fuse into helium. This process is called nuclear fusion, and it is the very reason why the sun shines. Every second, millions of tons of matter in the sun's heart are transformed into pure energy, which slowly travels outward until it reaches the surface and escapes into space. The journey of a single photon from the core to the surface may take hundreds of thousands of years, because it keeps being absorbed and re-emitted inside the dense material. But once it breaks free, it races through space at the speed of light and reaches Earth in just 8 minutes and 20 seconds. That energy is the foundation of all life on our planet. It drives photosynthesis, it keeps oceans liquid, it makes the air breathable, and it shapes everything about our environment. So if we ask ourselves, what would happen if the sun exploded, we first need to clarify what such an event would actually mean. The sun is far too small to end its life in a supernova. That violent fate is reserved for stars that are many times more massive. Our star, in reality, will one day swell into a red giant, engulf the inner planets, and shed its outer layers. What remains will be a white dwarf, a dense ember that will shine faintly for a long time as it slowly cools. That is the true and gradual destiny of our sun, expected billions of years from now. But if we imagine, hypothetically, that the sun suddenly exploded violently as a supernova, the outcome would be instant and catastrophic. Let us imagine those first moments. If the sun suddenly detonated, we on Earth would not notice it immediately. Because light and energy travel at the speed of light, the first sign of disaster would reach us only after 8 minutes and 20 seconds. This means that for those 8 minutes, we would go about our day completely unaware that the sun no longer existed. And then, in a sudden instant, the deadly wave of radiation would arrive. The explosion would unleash an unimaginable flood of energy in the form of gamma rays, X-rays, and countless other high-energy particles. Earth's atmosphere could not withstand the assault. Within moments, it would be blasted away. The oceans would flash into steam. The surface of the Earth would liquefy into molten rock, and the planet would be turned into a glowing ball of lava. All life would be eradicated in an instant. There would be no time to react, no possibility of escape. Every DNA molecule would be shredded, every living cell destroyed. From the perspective of biology, it would be total extinction. And it would not stop with Earth. Mercury and Venus would be obliterated even faster, their matter vaporized and scattered. Mars, though farther away, would stand no chance either. Its surface would be sterilized, and any traces of atmosphere blown away. The asteroid belt would fragment violently, sending countless chunks of rock flying chaotically through space. Jupiter and Saturn, the gas giants, might not be completely torn apart, but their dense atmospheres would be shredded and disturbed, their storms amplified beyond imagination. The moons orbiting them would be stripped, burned, or destabilized. Uranus and Neptune, though more distant, would not escape unscathed. Their rings would scatter, their atmospheres distorted, and their satellites subjected to intense radiation. The solar system would no longer resemble the orderly family of planets we know. We must also remember gravity. The Sun makes up over 99% of the mass of the entire solar system. Its gravitational pull is what holds the planets in their orbits. If the Sun were blown apart, that center of gravity would vanish. Planets would no longer follow their neat elliptical paths. Instead, they would shoot off on straight trajectories, moving at their original orbital speeds. Some would collide, others would drift forever into interstellar darkness, becoming rogue planets. The solar system, as a coherent entity, would cease to exist. Beyond the mechanical chaos would come the radiation storm. Supernovae are among the most destructive events in the universe, precisely because they emit colossal beams of radiation. Their gamma-ray bursts can sterilize planets and wipe out life over vast distances. If our Sun erupted like that, neighboring star systems within dozens of light years could be devastated. Any life forms that might exist there could face mass extinction purely because of our star's death throes. What would actually remain of the Sun after such a blast? In more massive stars, the core collapses into a neutron star or even a black hole. But because our Sun is not nearly massive enough, the most likely remnant would be a white dwarf, a tiny, incredibly dense sphere about the size of Earth. It would shine faintly with residual heat, but its days of nuclear fusion would be over. Along with it, an expanding nebula of gas and dust would drift through space, a ghostly reminder of the star that once powered a living world. For us humans, the experience would be incomprehensible. Imagine sitting outside on a warm day. The sky is blue, the sun is shining, and within a few minutes, the entire sky suddenly turns blinding white. The heat surges to thousands of degrees. The air breaks down into atoms. The ground melts beneath your feet. There is no time to run, no time even to understand. The catastrophe unfolds faster than the mind can register. That would be the end, not only of humanity, but of every single organism, every trace of life that has taken billions of years to evolve. Fortunately, this terrifying vision remains only a thought experiment. The Sun simply cannot explode as a supernova. Its mass is insufficient. Instead, what awaits is a far slower transformation. About 5 billion years from now, hydrogen in its core will be exhausted. The Sun will expand into a red giant, swelling until it engulfs Mercury, Venus, and very likely Earth itself. The oceans will evaporate, the atmosphere will be stripped away, and Earth will become a barren, scorched rock. This will not happen in minutes, but over millions of years, giving time for processes to unfold gradually. When the Sun finally sheds its outer layers, the core will remain as a white dwarf. That ember will continue to radiate faintly for billions of years before cooling into darkness. If we imagine a future civilization facing this fate, there are many possible scenarios. Perhaps humanity, or whatever descendants of humanity exist then, will have migrated to other stars. Perhaps vast, artificial structures, Dyson spheres, or engineered suns will have been built to sustain life. Perhaps entirely new forms of existence will have been developed. The possibilities are endless because the timescales are so vast that we cannot truly grasp them. What is certain is that Earth as we know it will not endure forever. The idea of the Sun exploding has a philosophical meaning too. It is a reminder of fragility. Everything we take for granted, sunlight, warmth, breathable air, is a gift from a single star. If it were taken away, nothing would remain. Maybe that is why ancient civilizations worshipped the sun as a god. They felt instinctively what we now know through science. Without it, there is no life. In the end, if the sun were to explode like a supernova, within 8 minutes, Earth would be struck by a wave of lethal energy. The atmosphere would vanish, the oceans would evaporate, the crust would melt. The solar system would unravel. Nothing living could survive. Yet that is not our actual destiny. Our star will end its life much more quietly, slowly expanding, fading, and leaving behind a pale ember. And in the meantime, we still have billions of years, time enough for humanity to search for new worlds, new stars, and new ways to exist in this vast universe.